Hello, my dear students, and welcome in the Indoor Environmental Control course. I am Associate Professor Kareem Galal.
This time I will continue to explain the heat science. The title of this lecture is Psychrometrics. Air is a mixture of oxygen and nitrogen, but the atmosphere around us is humid air. It contains varying amounts of water vapor. At any given temperature, the air can only support a limited amount of water vapor, when it is said to be saturated. Psychrometrics is the field of engineering concerned with the physical and thermodynamic properties of gas-vapor mixtures. Helps to control the indoor air conditions. The basic structure of the psychrometric chart are: dry bulb, air, temperature on the horizontal axis, and moisture content, or absolute humidity, A, on the vertical axis, in units of g/kg, grams of moisture per kg of dry air. The top curve is the saturation line, indicating the maximum moisture content the air could support at any temperature, which is the saturation humidity, SH. Each vertical ordinate can be subdivided, and the curves connecting these points show the relative humidity, RH, in percentage. For example, at 25 degrees Celsius the saturation A is 21 g/kg. Having the ordinate, we get 10 g/kg, which is half of the SH, or 50% RH. Humidity is best measured by the wet and dry bulb, whirling, psychrometer, or an aspirated psychrometer. These contain two thermometers. One has its bulb wrapped in a gauze, which is kept moist from a small water container. When whirled around, or the fan is operated, to obtain maximum possible evaporation, this produces a cooling effect, showing the wet bulb temperature, WBT. The other thermometer measures the air or dry bulb temperature, DBT. The difference DBT, WBT is referred to as the wet bulb depression, and it is indicative of the humidity. The sloping WBT lines on the psychrometric chart. These coincide with the DBT at the saturation curve. But wait, how can we make changes in the indoor air characteristics by using the psychrometric chart? It is called psychrometric processes. Heating is represented by the status point moving horizontally to the right. As the DBT increases, with no change in moisture content, the RH is reducing. Cooling lowers the DBT, the status point moves horizontally to the left. Cooling causes the RH to increase, but the A is not changed. Where this horizontal line reaches the saturation curve, the dew point temperature, dPT, corresponding to the given A, can be read. If the air is cooled below this point, condensation will start, dew will be formed. Below the dew point, the status point moves along the saturation curve, and the A corresponding to the vertical drop will have condensed out. Humidification, for example evaporation of moisture into an air volume, is said to be adiabatic, if no heat is added or removed. This causes a reduction of temperature, dBT, but an increase of humidity, both A and RH. The status point moves up to the left, along a constant WBT line. Such as the water sprinklers in Arafat to humidify the dry air in El Hajj period. Adiabatic dehumidification takes place when air is passed through some chemical sorbent, solid, such as silica gel, or liquid, such as glycol spray, which removes some of the moisture content, by absorption or adsorption. This process releases heat, thus the dBT will increase, whilst the humidity, both A and RH, is reduced. Thanks for following me, and I hope that I have explained the topic well.
This material is copyrighted. Associate Professor Kareem Galal 2021. All rights reserved.